So I'm going to take 5 minutes to talk about our theme, which is sustainable food, and what we're doing at the moment and what we plan to do in the future. So our mission is to be leaders in research on sustainable food systems and impact as well. And this is crucial. This particular theme is crucial at this moment in time. If you think about the challenge that faces the global food system, we need to produce 60% more food by 2050. And if we use the same agricultural system that we currently use, we'll need 120% more water and also 42% more land. And that production alone will lead to a 2 degrees rise in global temperature. So it's clearly not sustainable. It can't be business as usual. And this is also at a time, remember, and we heard about this morning from a number of the speakers, it's at a time actually when our food system is increasingly vulnerable. So just to look at a few examples of that vulnerability, if you take environmental degradation, in Europe last year, we lost 970 billion tons of topsoil, for example. You've got increasing political risk, not only, as Sue mentioned this morning, Brexit, but if you look at where our food comes from, and if you look at the Chatham House report, Maritime Choke Points, you will see that our food comes through shipping routes through areas of increasing political instability. And then you've got this ticking time bomb of the health and obesity crisis within the food system. If you consider that we, last year in the United Kingdom, nearly spent £1 billion worth on advertising sugary and starchy foods. This is if you look at the figures across the marketing industry. We only spent £10 million on raising awareness about healthy diets. So there's a real paradox there within our food system. Plus, paradoxically, you've got increasing food poverty as well and food insecurity within the United Kingdom. 1 in 10 children under 15 suffer from food poverty. So as a sustainable food theme, you can see we've got plenty to go at within YESI. It's a really, really complex and pressurized situation. And the statistics aren't getting any better. So if you look at the World Food Hunger Report, for the 3rd consecutive year, the number of people suffering or experiencing food insecurity globally is actually going up. That's despite all the focus on sustainable development goals and so on and so forth. We clearly need transformative, innovative, adaptive solutions, which was also called for this morning as well. Plus, you've got a real we think within YESI there's a real governance deficit also within the food system. So we talk a lot about the impact of climate change, the impact of the biophysical factors, but actually we're not doing ourselves any favors internally within the food system because we continue, there continues to be opaque supply chains that lead to human rights abuses like this. This is a story from The Guardian that focuses on the tomato industry and uncovers human rights abuses of migrant labor in Southern Europe. And that's despite the Modern Slavery Act. You know, we're still fighting these governance deficits within the food system. And this is what the solutions to these kind of problems is really what transfixes us within YESI. So all our research, and it's interdisciplinary research, we've got people working on sustainable food from right across the university, which is fantastic, and with other universities as well. So our aims and scope is really to look at more sustainable, resilient solutions, more integrated solutions from production to consumption that deliver real change within the food system, deliver sustainability and resilience. So we focus on production, supply chain, and also consumption. And sometimes those areas, the best research is where you can integrate those 3 areas together, rather than just looking at one component in isolation, which doesn't always tend to lead to the most sustainable or resilient food system solution. So just a few of those projects that these are just some exemplars And I'm not going to talk too long about them because Chris West and Richard Friend are going to talk about their specific projects within this. We have a 4-year funded program from the Global Food Security Fund called IKnowFood, which was led by YESI and enhanced by NA Agri-Food. So it's a collaboration across the University of York, but also with the University of Manchester, University of Liverpool, and the University of Leeds, brought together by the NA Agri-Food platform. And Chris West will talk about IKnowFood in detail. And then we have an institutional link with Chiang Mai University in northern Thailand, looking at resilience of food systems in those areas just above Chiang Mai in the uplands that have been negatively impacted by fast, rapid agricultural transitions. And that's led by Dr. Richard Friend, who's going to be talking about that particular project. It was one of only 3 Newton-funded projects that were awarded for institutional links last year by the Thai Research Institutes and the British Council. And then, thirdly, we have a project, an ESRC-funded project, in collaboration with Newcastle, Durham, Sheffield, and also Sun Yat-sen University in China, Cape Town University, and also Federer University in Rio, looking at sustainable consumption research in the middle classes in agri-food in the global south. And that's a real example of collaborative work, looking at changes looking at how you can understand the kind of motivations for buying sustainable food in the global south and whether you can manipulate that behavior going forward in the future. And then Dr. James Chong from biology runs now our new YESI Waste and Resource Use Network. So future plans. So we started to really work and shape industry strategy. So last week, the co-op launched their new Future of Food strategy, and we've been helping them for 17 months now shape that industrial strategy to make it, to have a food strategy which is more about food systems and more about resilience. We're developing a number of new collaborations, interdisciplinary collaborations globally and internationally. And we also increasingly want to influence policy, and we're working within the United Kingdom and also at the European Union level in terms of policy, because, as Sue said this morning, it's quite disjointed and it's not very joined up. And what we're trying to do is provide a food systems thinking and a sustainable and a resilience lens to try and enhance that food policy work, and also building new networks. So if you're interested if you represent a local pressure group or NGO or an academic for another university and you've got a great idea and you want to collaborate, then come and talk to us as part of today. I'm now going to hand over to Dr. Chris West from Stockholm Environmental Institute, who's one of the co-eyes on the IKnowFood project, and he'll be talking about in more depth about this 4-year funded program from the Global Food Security Fund. Over to you, Chris.
Thank you very much, Bob. Thank you, Bob. Thank you very much for the introduction. So as Bob highlights, IKnowFood is a 4-year funded project between the Universities of York, Manchester and Liverpool, and we're now about halfway through this project. So I'm just going to give a brief overview of the objectives of IKnowFood, as well as a short overview of the progress that we've made so far, and also our future plans. So IKnowFood really arose from a number of years of more informal collaboration facilitated across the YESI network and Agri-Food, and it really sits as a sort of microcosm of the sustainable food theme of YESI. It brings together a variety of disciplines from psychology to engineering to environmental science and others. As Bob mentions, one of the outcomes of that initial collaboration was this successful application to the UK's Global Food Security Programme. IKnowFood has the following objectives, the first of which is to identify the barriers or obstacles that exist to food resilience, which may be structural or institutional or informational in nature. To design approaches that overcome those obstacles, whether those are approaches of the provision of new data, new technologies, new modes of governance, or new tools or applications that can allow us to work directly with our food system stakeholders to induce change. And the third objective of IKnowFood is to set out a new vision for food system resilience, which brings together those disparate policy arenas that Bob just mentioned. Those overarching objectives are tackled across the food system, from food producers, the supply chain, to consumers, and brought together via a series of 4 work packages. The first work package is one that focuses on the food producers, and it's specifically designed to tackle the challenge of technology uptake in food production systems. And a key problem, in some cases at least, for technology within food production is that technological development takes an end-of-pipe approach to implementation. In other words, technologies are often designed with the purpose of providing a more resilient farming system, but fail to be uptaken because of the fact that they don't sit within the context of the farming environment. So IKnowFood takes a social learning approach to try and tackle this problem. It's about understanding how technologies should be designed in conjunction with farmers from the beginning, with an outcome of that work package being the prototyping of a series of technologies designed to address key challenges identified by farming groups. And to date, this work package has identified these farming groups. It's been working with farming groups to establish a set of key issues that could be tackled with technologies developed in Manchester. And it's been co-developing some core attributes that those technologies should possess in order to be successfully uptaken. And as we're halfway through the project, as you expect, the next stage is to actually start to prototype some of those technologies and move towards a greater understanding at the national level of what key issues and constraints might exist that may be a barrier or an enabler to future technology uptake. Work Package 2 focuses on food supply chains, and in particular, we're interested in international food supply chains. The UK, as was mentioned earlier, is increasingly dependent on food coming in to the UK from the rest of the world. And that complexity, the internationalization, the globalization of food supply chains, means there's a disconnect between points of production and points of consumption, which can mask risks and hide leverage points in those systems that might be opportunities for change. To tackle this problem, we bring together 2 research fields, one of which is supply chain modeling, which is aiming to make those connections between remote regions of production and consumption. And that's nested within political economy research, which is aiming to understand how private and public sector governance can come together with understandings of the supply chain to actually induce adaptation and reduce supply chain risks. To date, we've been modelling those connections, particularly in the space of soybean, which we see as a particularly complex commodity. And I've offered a critique of global value chain theory, which we feel is a poor representation of the complexity that exists within such commodities. Going forward, we aim to use the models to understand the broader context of UK dependencies on global food, the barriers that exist to a transition towards a more sustainable food system and food supply chains. And we'll be conducting stakeholder interviews going forward to understand how new modes of governance and new data can come together to inform decision making. Our third work package focuses on consumer, and it essentially focuses on the challenge that despite the availability of sustainable and nutritious food within the UK, we still don't have a model of food consumption where everyone has access to or chooses to buy such food. So this work package explores how aspects such as personal income status, marketing of food, other aspects come together to inform food consumption and food choice. And we're building on that work to design a number of mobile applications to help inform food choice and more sustainable food choice going forward. We've already conducted experimental studies looking at labelling and marketing, as well as offering a review of food aid as a mechanism to increase food security. And we've also been prototyping a number of apps around low-carbon food and food waste. And again, moving forward, we'll be looking to continue that work and move towards actually fully working apps, which will then be employed in retail space, in the retail space. And finally, Work Package 4 has the task of bringing all that together, so bringing together the learning outcomes across those different work packages, and also integrating knowledge that exists across the UK's food network, the stakeholders that we're trying to influence, to try and understand how new models, new ways of working, and importantly, how new policies can come together to increase food security and increase the sustainability of our food going forwards. We've already begun those discussions, and we're holding a couple of events in 2019 and 2020 where we will be sharing our knowledge of our outcomes from IKnowFood. And we're also developing a food systems handbook on food systems governance that we hope will bring together the leading thinking in this area. So that's what we've done so far. Obviously, still quite a lot to do, but thank you very much for listening.
Okay, good afternoon. Thanks very much, Chris. I'm going to slight detour to Southeast Asia and Thailand to talk about a new program, new project funded by the Newton Fund and British Council. Before I start, underpinning this project really was what was seen as a problem about haze in the north of Thailand. It was initially framed as an environmental problem that was attributable to the practice, the farming practice and the knowledge or the lack of knowledge of upland farmers in Chiang Mai province who were farming in such a way as to create this haze, which was then generating a problem for people living in the city or in the lowland areas around Chiang Mai. So we came into this work with colleagues in northern Thailand and started thinking about it in a slightly different way and thinking about it from what Bob was talking about, from this food systems perspective. So just to give you a little bit of detail, it's a project that's funded by the Newton Fund and the British Council and also with the Office of Higher Education in Thailand. It's a collaboration with Chiang Mai University, which is Chiang Mai is a main university in the northern part of Thailand. And in the spirit of YESI, it brings together lots of different kinds of actors, different disciplines within Chiang Mai, within our university as well, and really trying to make that bridge between research, knowledge, and practice. And what we're trying to do is sort of pull this sort of food systems thinking together with trying to situate particularly producers and consumers in how they are shaped by these emerging food systems and how they may be able to reshape food systems in a slightly different or in a dramatically different trajectory. And underpinning all of this is this sense that we have to think about how problems are framed. We have to think about the interlinkages between different scales, between different actors, between us here as consumers of some products that emanate from the south. And also underpinning all of this is an understanding of politics and power. So you've heard a lot about food systems. What do we mean by food systems? Well, it's not just academia that talks about food systems. This is taken from the website of Jerome Pokpan, which is one of the largest agribusinesses in the world now. It's a Thai multinational company that emerged about 20, 25 years ago. They don't necessarily talk in an academic way about food systems, but they've got a very neat business application of food systems, where their ambition, which they're realizing to a large degree, is to link really seed to plate, to link the whole production and the inputs of what goes into production with what's consumed. So as well as providing seed and the chemical inputs for farmers, they also run the 7-Eleven corner stores that sell all the fast food, ready meals, and a lot of what we produce, perhaps even what we had at lunch, comes from CP in some way. Okay, so you've got a very strong business application of food systems. And it's very, very effective. They've grown enormously. They're hugely influential. But when you look at the big picture, and you look at the big planetary picture, as we heard this morning, or you look at the food systems picture that the multinationals that produce, you often lose the significance of the individual farmers, the households who are caught up in these food systems, and whose practice is really shaped by forces beyond their control. And so what we're trying to do is really understand the role of these farmers in this upland area, largely ethnic Karen, and how they are pulled into these food systems and what it means. And very significantly, in this part of Thailand, they're upland people, marginally ethnic minorities, who don't have land rights, who have struggled to gain citizenship rights and whose traditional practice of swidden rotational agriculture has been prohibited by the state and by a variety of state practices in claiming that territory. And what we've been doing is really sort of mapping the systems in which these farmers are being caught up, and to understand how they access seed, how they access knowledge, where their products go to, how they're able to make decisions, because there's a core problem for them that they do not benefit. That the price of corn, of animal feed corn, is so low that they're in debt. And once they're in debt, they're caught up in a continuing cycle of producing the same animal feed corn and yet getting further into debt. But for CP, this is a marvelous mechanism of reducing one of the main costs of animal production, of pork and poultry production. And so CP and others have been targeting these marginalized upland areas in Thailand and other countries. And through this very, very elaborate network, because they've actually signed up to an agreement that they will not purchase any animal feed corn from farmers who don't have land rights. And they don't directly, but they do through a whole complex web. So I'm going to sort of wrap up and just give you a sense of what we're going to do. Our approach is about co-producing knowledge, so we've got a whole series of processes that involve different stakeholders, different actors, academics, farmers, also the private sector as well, in thinking about the fragility and potential failure of these emerging food systems. And we hope that this is really going to be the basis for a much wider engagement in this part of Thailand, but also in the Mekong region, which is a major food producer for the whole world. And that's where I'll stop for today. Thank you.
It's time for questions, so fire away, guys. So there's one there in the middle row. If you wait for the microphone and just perhaps say who you are, and if your question's directed to someone in particular, then say so, otherwise they can all have a go.
My name is Ashley Burgess. I'm a friend of York, and in particular interested in antibiotics. What I see or heard no input about the antibiotic resistance problem on intensive livestock production in Thailand, Vietnam and China, which is absolutely massive.
Yeah, I mean, it's a good, very, very good question. One of the beauties of being part of the NA Agri-Food platform is that we're able to engage with where that expertise does lie across the Northern 8 universities. And there's a group of academics at Liverpool who work on antibiotic resistance within the Mekong region and also within East and West Africa as well. And you know, we had a meeting with one of those people last week. So when we put these big collaborative programs together, for example, to look at food systems in the Greater Mekong region, we would bring that expertise into the team. We don't necessarily have that specific expertise within YESI, but we do know where to go and get it. But it's a very important fact. You know, it's a very important topic, and you're right to raise it.
Okay, other questions? Oh, there's another one just further along there.
Thank you.
It's very hard to see.
In the past, have food production systems ever been resilient?
Oh. Who wants that question? Chris?
Or are we trying to, you know, create something that is uncreatable?
Who wants to tackle it?
I mean, I think what we're aware of is that there are new stresses, potential crises and shocks that are emerging that perhaps we haven't witnessed before. And the way in which food systems are interlinked to the global scale is quite different from how they've ever operated before. I think also there's a fundamental question about justice and equity. And the food systems that have generated, you know, some clear benefits for some and that generate food, cheap food for us here, come at a very serious cost.
Yeah. Chris, did you want to answer something?
I mean, I think it's a very challenging question and thought-provoking one. I mean, I think the other aspect to it is that obviously we now operate within an environment where food provision is not just a subsistence activity. You've got various industries tied to it. You've got the geopolitical aspect. You've got local politics tied to food provision. And therefore, as Richard has said, actually the complexity of it is now a much larger problem. So whereas before, if there was a crop failure, you may have reserves, and actually that might affect a relatively small part of the global society. Actually, the interlinkages now means that the ripple effects of a potential catastrophic failure can ripple out into many different areas, and we've seen examples in North Africa of that resulting in conflict and other aspects and having those impacts. So I think it's not necessarily that the food is more or less resilient, I think, than maybe previously, but the impacts of the lack of resilience are probably much greater.
Yeah. Okay, one more question. Oh, there's one there and the third, fourth row, well spotted. Yeah. Sorry.
Hello, I just wanted to comment on the previous question. Do you not think having variety is one of the answers? You know, I grow things in the garden. If it's a good year for one thing, it may not be a good year for something else. And the more variety there is, the more resilient, you know, you're going to get something. Growing things on, you know, monoculture and so on and so forth isn't very helpful in terms of resilience.
I think that's a very good point. If you look at the resilience literature, certainly diversification of crop type is seen as one of the factors to build resilience. And I think if you look at where we get our, particularly our carbohydrates from, it's from only eight crops.
About half of it.
Nearly 85% of our global carbohydrate supply. So that's obviously, if you think that those crops are growing in areas where they're increasingly vulnerable to changing weather patterns and political instability, that's obviously a concern. So I think when you can build diversity, you know, the US food system is a good example of that, where you've got, particularly if you look at California, you've concentrated a lot of vegetable and nut production and fruit production in California, which is very, very water stressed. And they've lost that diversity of producing some of those crops in other regions, which is problematic, I think.
Yeah. I mean, can I just come in? I mean, I think it's an interesting point. I mean, going back to what Chris was talking about kind of global land use caps going forward. Actually, one of the reasons we've got monocultures, if you like, is that actually the efficiencies associated with those systems are typically much higher in a mixed cropping system. So any attempts to go back and refresh and reframe how we produce food would have to bear in mind that actually that may result in changes to the way we're using land and may become less efficient.
Trade-offs. I think we'll take one last question. I think there's somebody there in that row, and then we'll have to move on. Thank you. Yeah.
Hello. Forgive me if I've misunderstood, but I keep flashing back to Gaia's picture of the supermarket with all the crazy things that we really don't need. Are we talking about producing food to sustain that sort of production, or are we talking about sustaining food that we need? Does that make sense?
Yeah, that was my desk, actually.
I mean, there's a kind of a controversial tension. I mean, there is a topic that I think we're all going to have to face, is that we use a lot of land for producing crops that are used for animal feed and the kind of products you see on those supermarket shelves, and that's not sustainable, I don't think. So we are going to we'll you know, the forecast is we'll need to use that land for other, you know, for. There's no reason why humans can't consume those crops rather than livestock. Yeah. So I think there's a lot of a lot of transformation that's required, both in terms of land use and diet, which we actually do face as a planet.
Yeah. Yeah. Thank you. I think that's a good point to end on transformation, because we're going to transform now to our next session. Right. So thank you very much, guys, for your sustainable food theme introduction. So it's a great pleasure to introduce the next speaker, myself. And of course, Jane Hill is the leader of our Resilient Ecosystems theme, but she's busy, hopefully, improving the resilience of ecosystems in Thailand. So I said I would introduce this theme on her behalf. So the mission of this theme is to understand the drivers of biodiversity changes and protect the benefits that biodiversity provides. And I think the talks we heard this morning really set us an interesting perspective towards that. What sort of biodiversity, which biodiversity? And we have a number of challenges at the moment. The government has committed, amongst a number of other commitments that they're unlikely to meet, but they've committed to halt the loss of biodiversity in order to ensure that by 2020 ecosystems are more resilient. And of course we are subject to a lot of international agreements, and this particular one is the Convention on Biological Diversity. Chris has already mentioned this morning the Living Planet report showing that the abundance of many species is declining, although some species, as we also heard, are adapting and doing much better. One thing we are clear about, particularly today after the IPCC report, is that global climates are changing, and so species are going to have to adapt or go extinct. And we've already heard just how many species are adapting. And one of the main themes within this research area is around that speed of that adaptation of UK biodiversity. And Jane is leading a collaborative project on how some species that can benefit from climate change are shifting their ranges northwards. But of course, the speed at which different species can do that is going to depend on a number of things, partly their own kind of evolutionary capabilities, but partly the ability of habitat to allow them to kind of stepping stone their way northwards. And in collaboration with Liverpool, we're looking at using computer models to map habitat connectivity and help design landscapes that are better connected so species can move more easily. Now, of course, one of the things that fragments habitats is when they're degraded or converted into agricultural land. And one of the areas of the world where that's happening is in Malaysian Borneo, where much of the forest is being converted into oil palm plantation. And there are a lot of work going on within this theme on looking at the impacts of certification schemes for raising the environmental standards of oil palm cultivation, and to understand how we can better design those landscapes so that species can better adapt to those changes. So the theme aims are to advance knowledge of the drivers of biodiversity change and its impacts on ecosystems, to understand, as I've said, the adaptation to environmental change and the factors that either promote that or prevent it. And the focus areas are very much around biodiversity conservation and ecosystem services and climate change. So, current projects, you're going to hear in just a moment from Susanna, who's going to tell us more about oil palm certification standards, the Sensor project. I've already mentioned the Evolutionary Limits to Climate Change project that Jane leads, and there's some more information about that in your little research portfolio packet. And then we're going to hear from Eleanor in just a moment about Tropical Peatland Restoration Project. And we have two networks relevant to this theme, the Tropical Ecosystems Network and the Climate Change Network. And hopefully you have a chance to hear more about those over the lunch break. So future plans. We're very much interested in working with businesses to develop new ways to restore habitat connectivity. A number of companies, including Unilever, have been very involved in the oil palm work and the design of landscapes in Malaysia. And we've been talking to organisations like Three Keel, Nestle and the Woodland Trust about better connected landscapes for UK woodland. You've probably heard about the so-called northern forest, northern treehouse, we sometimes call it, and how to actually design that across a landscape is going to require some sophisticated planning. We do a lot of international, interdisciplinary research, and you're going to hear 2 projects that are largely international in a moment. We're trying to influence policy on landscape scale conservation. They're very much following on from the Lawton report. With my Natural England hat on, I think about this a lot, how we can have larger scale, longer term, bigger, better and more joined up conservation. And as I've mentioned, we're very keen to build new networks, both in the UK and globally, to address these issues. So that was a bit of a whistle-stop run through the theme. So I'm going to hand over now to somebody who's actually doing some work in this theme, and Susanna's going to tell us all about the Sensor project. Thank you.
So I'm a PhD student, part of the Sensor project, which is conducting research with the aim of improving the sustainability of palm oil. So palm oil is one of the major drivers of deforestation, particularly in Southeast Asia and increasingly across the whole of the tropics. And the 2 main environmental concerns to do with tropical deforestation are firstly the loss of habitat for a huge amount of biodiversity, and secondly the carbon emissions that come from cutting down trees and release of carbon from the soil. So to illustrate this, you can see on Borneo since 1950 there's been a huge loss of forest, and a lot of this has been driven by expansion of oil palm plantations. So what the Sensor project does is it looks at the criteria for certifying palm oil as sustainable, and we test whether these criteria are effective, so we gather scientific evidence and make conclusions about that. And then we also use what we find to make recommendations about how these criteria could be improved. And our focus is on collaboration with the Roundtable for Sustainable Palm Oil, which currently certifies just under 20% of palm oil, all palm oil, so it's a major part of the industry. And I'm going to take you through a bit of my current research to illustrate how we work with the criteria and then how we end up making recommendations. So one key outcome of the current criteria of the RSPO is that oil palm plantations maintain small patches of forest, like this area here, inside the land that they own. And that could have really important implications for conservation. It could maintain rare species and also for carbon storage, because these areas of forest hold carbon, which is important for global greenhouse gases and hopefully mitigating climate change. So my aims in this part of my research are to quantify the carbon that's stored in this kind of forest patch that's owned by the plantations, and then assess what kind of factors, say, in the surrounding landscape or actually in the vegetation structure, drive the carbon, and how we could recommend that plantations maximize the carbon that's stored in these forest areas. So my findings are that these forest patches, which are on the left, generally store lower carbon than continuous forest, which are on the right. Here's logged forest and primary forest, which isn't surprising because they're small and often really degraded. They have a huge amount of variation in the carbon stored, and that's really important because the highest amounts of carbon in these forest patches are actually equivalent to the carbon in continuous forest. So that's very positive, and it suggests that the criteria is a good one. In general, yeah, you can see that the carbon is greater than that of oil palm plantations. So if you look across the landscape, that means that overall keeping these areas of forest is helping mitigate the total amount of carbon emitted when oil palm plantations are created. So a key finding of my research is that this criteria that leads to maintaining these forest patches is really important for carbon storage. And I'm still working with my results, but we also make key recommendations to the RSPO, and something I'll probably recommend something along the lines of the best ways that companies could design and manage these areas to maximise the carbon they store. And as a Sensor project, we produce these Science for Policy reports with our key findings and recommendations, and they go straight to the RSPO, and we hope that they incorporate our findings into when they update their criteria, which we've seen over time. Yeah. Thank you.
Thank you very much, Susanna. Classic case of research with impact there. And we're now going to hear from Eleanor about peatland ecology.
So I'm Ellie Warren-Thomas. I'm a postdoc in the Department of Biology, and I'm going to talk about our research project looking at tropical peatland restoration and the effects of that restoration process on local communities and on ecosystems. Our project has a number of partners. I'm not sure which button. There we go. So we work closely with social science researchers at the University of Leeds, remote sensing, so that's satellite imagery analysis experts at ZSL, connectivity modelling research experts at University of Liverpool, and of course our Indonesian partners, the Soil Research Institute of Indonesia and University of Jambi, who work respectively on greenhouse gas emission research and on ecology. So why are we interested in tropical peatlands? So in tropical ecosystems, peat forms underneath tropical forest. Tropical trees die, and under acidic and waterlogged conditions, they remain only partly decomposed, and they form these very thick deposits of peat soil that contain enormous stocks of carbon. Within Indonesia alone, where we focus our research, the total peat soil carbon stocks estimated to be 57 gigatons, which, if that's translated into carbon emissions, is about 5 times the 2016 emissions from fossil fuels and industry of the whole world. So these carbon stocks are tremendously important for thinking about climate change. And also these forests contain really important specialised and threatened biodiversity. The acidic soil conditions mean we have very specialised plants and specialised fish that live in these forests, but also they support our well-known kind of flagship species of tropical forests, so tigers, orangutans, and things like that. So the problem is that as we run out of land to plant crops such as oil palm and acacia for pulp and for paper, these tropical peatlands are drained of the water to make them usable. The trees are cut down from the forest, the land is cleared using fire, and there are some, well, we have the land available for agriculture, but there are some really devastating environmental impacts of this process. So carbon emissions I've already mentioned. Land subsidence, when peat dries out, it collapses, it decomposes, and it actually, the land surface falls. The fires that are used to clear the vegetation to enable you to plant crops actually end up setting fire to the peat itself. The ground sets on fire. And that resulted in 2015, most recently, a toxic haze crisis where airports were shut down. People died of respiratory illnesses. There was enormous economic damage. And it was called this Transboundary haze crisis. So fires in Indonesia were affecting Singapore, affecting Malaysia, affecting Thailand. And of course, biodiversity loss as you lose the forests. So the Indonesian government, in light of these devastating environmental impacts, announced a plan to restore 2 million hectares of degraded peatland by 2020. And yes, that's only 18 months away. So our research is looking at what the likely effects of this restoration and these restoration processes might have for communities, local communities who live on these peatlands, and also on biodiversity. So the research project has a number of strands. I'm going to whiz through a few of them as an illustration of the kind of work that we're doing. So here we're looking at the island of Sumatra in Indonesia, and that box outlines our study landscape. And one of the things we've been doing is coming up with accurate maps of land cover on peatland. If you want to plan restoration, you want to plan for what happens to land use, you need to know what is there to start with. One of the things we're using this map for is to think about connectivity, which Sue already mentioned. So this map here is of Jambi province, where we focus our research. And the yellow areas are peat soils, all of which were forested in 1990, pretty much. And the green areas are the forest that's left today. And we know that when you have these isolated patches of forest, organisms that depend on forest may not persist in them in the long term. They need to move. So what we're doing is some modelling work to try and understand how you could plan restoring forest in this landscape to improve connectivity. And we can do things like ask the question of what would happen if we only restored degraded land that's currently unproductive, no one's planted anything, so there wouldn't be any economic losses of restoring those areas, and try and make recommendations about how restoration could improve connectivity. Something else we're doing is thinking about the impacts of restoration for farmers who live on these lands that have been drained. So one of the main things that peat restoration involves is stopping this drainage and blocking the drainage channels that have been used to lower the water levels. If you re-wet the peat, the carbon emissions from decomposition fall, fires become less likely, but it means your land is wetter. So what happens to your yield of your oil palm? The land was drained in the first place for a reason. And something else we're interested in is how farmers actually get around their landscapes. So a lot of these drainage channels are used for transport. So we've been doing interviews. My colleague, Caroline Ward at the University of Leeds, has been interviewing local communities to try and understand how they use peatland, how dependent their livelihoods are on the oil palm that grows there, and their perceptions of what canal blocking will mean for them and for their futures. We're also serving biodiversity in these landscapes. This is the landscape we're working in. This is a block of forest. It's about 10 kilometres across, 15 kilometres north to south. The communities we're visiting and interviewing people in are all around in this yellow area, which is the oil palm. And we're also doing these field surveys. So we're installing, or we have installed, these dip wells to monitor the water tables, to understand the different effects of drainage in other different parts of the landscape. We're doing vegetation surveys to understand the structure of the forest and to understand management of the oil palm farms. Management differs widely from farm to farm. Part of that is to do with soil wetness, part of it is to do with farmer decisions. So we're looking at that, and then we're looking at how biodiversity responds to those variables. So it responds to the water tables and responds to the vegetation. So we've been doing bird surveys. These photos are all from the Indonesian project ornithologist, Panji. And we're already showing that that remaining forest fragment, isolated as it is, supports incredible biodiversity. We've seen tiger footprints, we've seen tapir footprints, we have had gibbons singing every morning, we saw a sun bear. And also many of these bird species are declining in their numbers. And we're also seeing that oil palm management does vary from farm to farm. So we'll be thinking about the impacts of that for biodiversity and also for livelihoods. So altogether, this research project is looking at how we may be able to manage peat landscapes better to improve connectivity, to support biodiversity, but also to maintain people's livelihoods and ensure that peatland agriculture and the peat forests are there in the long term.
So we've time for a couple of questions, and needless to say, can you please ask the questions to these guys? And remember to say who you are and where you're from.
Hi, it's Jasper Kenter in Environment and Geography again. Got a question for you, Susanna. I was curious about whether you'd looked at any other ecosystem services, or if not, whether you kind of had any intuition about whether there were trade-offs between different ecosystem services, so carbon and other things like flood and other kind of local benefits people might gain from those plantations or forests, or whether there were synergies.
Okay.
So I haven't looked at them yet, but that is part of ongoing work. And the way these areas are designated, they're actually set aside if they've got certain species or rare ecosystem, or if they're say important for a certain ecosystem service like watershed protection. So usually they will be important for some kind of ecosystem service. And I mean, forest in itself, particularly on slopes, is obviously important for it. Carbon storage goes in a synergy with, say, watershed protection and protecting from erosion. So I think there are a lot of synergies potentially trade-offs as well. For example, if local people want a food source such as like protein from bushmeat, then but there aren't very strong populations of mammals, there might be a trade-off there. Yeah.
Okay, thank you. More questions? Oh, there's one up there, look. Oh, yes, behind you.
Where do the human populations that you're talking about in peace forest conversion come from? Do they come from the area, and what did they do before this happened? How are they affected by all this?
I guess you could both comment on it.
Yeah. So in our landscape, there's a real mixture. Of where people have come from. So in Indonesia, in the 1980s and 90s, there was a transmigration program where people were. It was a government-sponsored program to move people from Java, which was very overcrowded, and people were struggling for space for agriculture, moving them to other parts of Indonesia. And Sumatra was one of those places. So the area to the east of that forest was designated as a transmigration area. The land was parcelled up into 2-hectare blocks and given out to families from Java in this government-sponsored programme. That happened a while ago. In fact, that was one of the earlier programmes. I think that was the 60s that it actually happened in that area. So those people have now moved on, they've mixed, they've sold land and things like that. So they're from Java. The people on the other side of the forest to the west are actually from Sulawesi originally, not from Sumatra. They moved by themselves, spontaneous migration. And their agricultural practices are a little different. They're a bit less connected to markets. So they grow a mix of crops, not just oil palm, but also coconuts and betel nut as well. So that's where they come from in that particular landscape. In terms of how they're affected by what's happened, those people don't gain very much benefit from the remaining forest. When the forest was cleared originally, there was a lot of commercial logging. That money went off to companies, but there was some kind of logging on the side that local communities benefited from. Now their livelihoods are dependent on the agriculture from those converted areas. So one of the key questions is now thinking about, as government kind of top-down policy changes about how you manage those agricultural areas, and these canal blocks and modifications to drainage are being imposed upon them, what impact that will have on their livelihoods. And that's one of the key questions of our research.
Anything to add, or take another question?
Yeah.
Okay. More questions? Oh, there's one there. Look, sorry. Yeah, you have to wave. I'm blind as a bat down here. Fruit bat or something.
I'm just me. It's, I think, a question mainly for Susanna. You talk about creating pockets of protected wood forest within the palm oil. What's the comparison between doing that if you assume that the total amount of land used for oil palm is going to remain the same, compared with keeping a single integrated bigger piece of forest? How does that environmentally and ecologically trade off?
That's a good ecological debate. So I think it would probably be... The forest would remain more intact if you had one area of forest where the whole area was just... where everywhere else was oil palm and then the forest was next to that. But... and probably populations within that forest would do better, whereas if you have fragments, some species are likely to not be able to survive because there aren't, say, with rare trees, there would only be a few individuals and the population wouldn't be able to reproduce in that fragment. But in the tropics, there's a huge amount of beta diversity, so that's where when you move across space, you get different species in new locations. So if you have fragments dotted around a huge area, then actually they might support different species from each other just because that's the way the landscape would have been if we didn't interfere with it anyway, that there are lots of different species across space. Yeah, so that's one part of the answer. Could carry on.
And from a connectivity point of view, there is a raging debate and lots of different levels of evidence for whether a clumped area of natural habitat is better, and then a big area of agriculture is better for biodiversity overall than having a mix of the two in space. But from a connectivity point of view, if you do have a very isolated area, albeit quite large, the species may need to move, whether it's for range shifting, for climate change, or to find new mates, or to find new food sources, or something catastrophic happens disease-wise in that area of forest. So if you have a completely isolated block and something devastated happens, all your eggs are in one basket, if you like. So it's quite a complex situation.
I think it illustrates quite nicely, doesn't it, the value of interdisciplinary approaches, everything from understanding the sort of population dynamics of isolated populations right through to understanding about people's livelihoods, and also, of course, how best to design the landscape through modelling approaches. So your work bringing all those things together is really important. So have we got any more questions? Oh, bless you. If not, well, actually, that means we're bang on time to move on to our next theme. So thank you very much.
So I've been given the job of introducing the urban living theme, and this is going to be a triple act. So I'm going to give a very quick introduction, and then I'm going to hand over to Annabelle and John, who are going to talk about a couple of the projects that we've been working on. And what the theme is all about is understanding the links between the quality of urban environments and ecosystem health and human health and well-being. And what we're hoping is, by having a better understanding of those interlinkages, we can manage urban environments much better for the benefit of ecosystems and humans. And I think we heard this morning why that's important. So we're now at a stage where 50% of the planet live in urban environments, and that number is forecast to shoot up. So by 2040, 60% of the population will be living in urban systems. And I think, as we all know, a lot of the urban systems that we reside in are not particularly great in terms of their environmental quality. So we saw a picture from Dhaka this morning. You see the classic pictures from Beijing and other cities in Shanghai, like Shanghai, with very, very poor air quality and water quality and very poor environments to live in. This picture is not Shanghai or Dhaka or Beijing. This is Astana, which is the newest capital city in the world, which I think is about 18 years old now. And if you're not, unless you're a fan of Las Vegas, it's a classic example of how you shouldn't design a city. So if you go to Astana, while it's a very new city, a lot of money has been invested into the city, so the investment isn't a problem. The environment is terrible. So around the city, you can see these power stations. They're using very poor quality oil as their fuel. So they're belching out some quite nasty emissions. If you go in the winter and you walk around the city, when you get back to your hotel, you've got this nice sort of blacks smearing all over your face. It's not a particularly nice environment to live in. So what the theme is all about is how we can sort of do this better. So what we're trying to do in the theme then is really to begin to advance our knowledge around the environment of a city or an urban system. And if we can do that, we can then begin to use that knowledge to sort of run cities better and design cities better. We have a number of focuses, or foci, should I say, and you'll hear a couple of those in a moment. So we do quite a lot on pollution in urban systems, and John is going to talk on some of the stuff we're doing on pharmaceutical pollution. So we had the question earlier about antibiotics. Antibiotics are one of the classes of drugs that we look at. Linked to that is health and well-being. So we're interested in the health and well-being of a city. But we recognise that the environment of a city isn't just a question of air quality. It's much more holistic than that. So we're interested in the natural environment. We're interested in the cultural environment, the social environment, and the heritage of a city, and how you can begin to sort of exploit that to the benefit of the citizens of the city. And partly what we're trying to do is illustrated in this diagram here. So this was actually a diagram that came out of a big EU project that was run by YESI. This was the capacity project, and this employed 12 PhD students to sort of look at how we can better monitor city environments. And the students came up with this concept, which really shows how we can begin to use electronic expertise, citizen science expertise, social science, big data expertise to begin to understand city environments and beginning to sort of design city environments better. So it's a really, really good topic for YESI people to get their teeth into, because it's very interdisciplinary and it's very intersectoral. And what Annabelle's going to do in a moment is explain how we've taken this type of concept and we're trying to employ it in York. So I'll now hand over to Annabelle.
Thanks very much, Alistair. So it's very much with that integrated approach that we came up with the idea for the York City Environment Observatory. And this project started in the summer of 2016. The whole aim of the observatory is to set up York as an exemplar city for trying to understand any linkages between the environment and health and well-being. And as Alistair says, we don't mean environment in a strict sense of sort of the natural and the built environment. We are very much talking about cultural and social aspects as well, which, as we've heard a few times today, makes this a very interdisciplinary approach, which is so important. So, thinking about the observatory, we want to gain this understanding between the environment and health and well-being, but we're very aware that there's no point in having an understanding if you don't also use that understanding. So what we'd like to do with the observatory as well is to try to help people to make decisions based on how we interact with or we use the environment, or perhaps how we plan and manage the environment as well. And these types of decisions could be from the scale of individuals. So it could be designing an app to help you to decide, we are in York, about whether you want to go rowing tomorrow morning. And it could go very broader decisions based on if we have a hectare of land within the city. Do we use that hectare of land to build 1,000 houses, or do we use it for farmland? What crops do we grow? Or do we turn it back into meadow? So, because these decisions all are very much based on evidence, you won't be surprised to see in the middle of this that data and analytics are right at the heart of the observatory approach, and I'll talk a little bit more about those in a moment. But the first thing that I'd like to say is that there's no point in having this understanding and all of this data and information if we don't use it to match the needs of stakeholders. So they would be people who these decisions affect, but also people who, what do people find important and where should we be targeting our approach? And this is why the first stage of the observatory was very much to have a co-design, and our team of researchers, some of whom are in the audience today, they went out and they talked, had face-to-face consultations with over 100 members of the public, perhaps some of those are here as well, and some more via some internet, some online questionnaires. So we don't have time today to go in depth through what we found during this co-design approach, but there were some very broad themes, things that the members of the public found to be very important. My favourite thing that came out of it is when people were talking about air quality. From an academic approach, we might have a very staid opinion in our mind. Air quality, we might think very negatively. But in actual fact, when people were talking about pollution, somebody said that they thought very positively about the air quality in New York. And you might think, well, why is that? In fact, if the wind is blowing in a certain direction on a very specific day, the whole city of York fills with the smell of chocolate from one of our factories. And it really hammered home the fact that this co-design approach, this really talking to stakeholders is so important, and not relying on your own assumptions about what people might be thinking and saying. Okay, so that's talking a bit about the stakeholders, but back to this sort of central core idea of the data and the analytics. So, we were actually co-led between the University of York and the City of York Council. And this demonstrates in part how much effect this type of approach can have for policy making in the future. But during this pilot phase of the study, the City of York Council really helped with the collection of data. So they have something called the York Open Data site. And this is an online site that anybody can go to. You don't need to log in, and you can just browse through all of the information that the council can make available about things in and around York. And as part of the Observatory project, what they did was they made as many bits of information as they possibly could relating to the environment around York and health and well-being available on an observatory-specific part of this York Open Data site. And in actual fact, currently there's over 1,000 data sets in that set. So some of them would include air quality, and this is a sensor that was put up on some of the street lamps in York as part of a sister project. So you can go on there and find air quality data through York. You can find out things like waste information. You can find footfall and the number of cyclists at different points throughout the city. One of my favourite things is there are some tree maps on this site. And this is all really related to York, but in actual fact, I can't represent visually the number of possible sources of data that we have. It's an almost unlimited number. And more moving into the future, we have ones like social media. So what information, useful information, can we get from social media perhaps moving into the future? Now, in this bottom corner, a nice thing about the observatory is that it's going to provide us with a space to develop. So you could have, for example, different monitoring techniques. So ways to collect data about what's actually happening in York and beyond. And this is one of Alistair's robots. It's a prototype. So the idea would be that you might have a fleet of these robots that you'd put into the rivers in York or watercourses in York, and they would take automated readings of water quality. And something that Alistair mentioned again is that pollution could be a lot of different things. So they talked about pharmaceuticals before. So if you think about the drugs that you took this morning, your medication that you wash down with a cup of tea, as the day goes on, your body uses some of those drugs. But in actual fact, the drugs that aren't used by your body then get washed out. And not to put it too delicately, these then would be taken into the sewage systems, where they'd be treated, but then the drugs themselves would flow into the rivers. So this would be an example of an innovative way to monitor a lot of different types of pollution that might happen in York. But one of the most important things to remember is that we're not just talking about the here and now. A lot of the decisions and a lot of the understanding is going to be about the future. So, for example, are you going to go rowing tomorrow? So there's some predictive element. And also then, well, what about those 1,000 houses that you plan to build? You might be wondering what the effect is going to be for the next 50 years. So you need to have this crystal ball. How do you predict the future? And that would be through the use of models. And models have been used a couple of times, and you can use models to gain a greater understanding of a system, but you can also use models in this sort of magic predicting the future kind of way. And the most famous example is probably the Met Office weather model, where they use readings of current weather conditions, but then use a lot of, I'm not going to go into details, use a lot of very clever calculations and algorithms to try to then look forward and give you a probability of what the weather might be for the next few days. So what I'm going to do now is I'm going to pass over to Dr. John Wilkinson, who's going to talk about a model that he's been developing that looks at the pharmaceutical levels in York's watercourses and beyond. John?
So where I'd like to start is that there are many different types of contaminants in our environments that ultimately result from our own use. And once they reach the environment, we know that many of them have knock-on effects that reach far beyond us humans. Take pharmaceuticals, for example. There are currently over 1,500 different pharmaceuticals in use every day here in the United Kingdom. And we know that some of them, once they reach the environment, have effects on non-target organisms such as fish that include endpoints like reproductive dysfunction, and all the way down to microorganisms, as we heard earlier about antimicrobial resistance in the earlier question. The selection for this resistance to antibiotics and antimicrobials such as that in bacterial communities is a real problem facing us right now. And when you think about it, it sort of makes sense. Medicines are, in fact, a biologically active chemical. We take them because of that reason. And ultimately, our bodies don't use everything that we take, and they will enter the wastewater treatment systems and will enter the aquatic environment where they still are biologically active compounds and may affect organisms living there. And it's out of this backdrop that the iPiE project was born here at the University of York. And the challenge here is to identify these risks to potential contaminants early in the development of pharmaceuticals. And of those 1,500 that are currently in use, we're also aiming to sort of figure out which ones of these actually are something we need to worry about. One of the ways we do this is to actually measure how much of these pharmaceuticals are in the environment. And we've actually gotten quite good at this at the university, at taking a sample of water and figuring out with a high level of accuracy what amount of pharmaceuticals are actually in the water. The problem here is that it takes us quite a lot of time and, believe me, even more money to do well. So one of the aims of the iPiE project, therefore, was to eliminate these impediments and come up with a modeling approach where we can estimate the concentration of medicinal contaminants in the water without the need of actually going out and measuring them. One of the ways that we do this is starting with the amount of these pharmaceuticals that are used. So that includes usage information on prescriptions, the NHS, for example. We'll then factor in the extent to which our bodies and the wastewater treatment network degrades the compounds before they're ultimately discharged. And then we'll use hydrological data on the water body in question that they're being discharged into to determine an ultimate concentration that we'd expect of that pharmaceutical. What that looks like is a little bit like this. It's meant to be a video. Well, anyway, I'll explain it. What this looks like is a catchment-based approach to the model. Here we go. So we can actually estimate over the entire river catchment, this being York as an example, and we can use spatial hydrological data to zoom in and get estimates on exact points within the river on what we would expect to be there, pharmaceutically speaking. And once we have a fairly robust idea and confidence in what's actually in the river, that opens up the door to a lot of really cool possibilities of what we can do with that model. One of those includes incorporating what we know about toxicity of pharmaceuticals directly into the model. That is starting out with just the data on how much of a particular pharmaceutical we use and working it into what could be the implication of that pharmaceutical in the environment. One of the projects that's doing this quite well right now at the University of York is the Virtual Fish Ecotoxicology Lab. And as the name suggests, it's doing just that. It's taking these predictions of what we think is probably in the environment based on what we use and how we process these drugs after use, and linking them up to what we know about the effects that they can cause. And ultimately, what we want to do with this is direct the most effective use of resources and funds to study drugs which are which pose the highest risk of actually causing an effect in the environment. Of course, there's much still to be done. And to sort of wrap up what we've been talking about over the last 20 minutes or 15 minutes, I'll pass it back over to Alistair. So thank you very much.
Thanks, John. So hopefully that's given you a bit of a flavour for some of the stuff that we're doing in the theme. But just like the other two themes, we are looking towards the future, and these are some of the things that we're planning to do. So Annabelle mentioned this, we're sort of interested in looking forward, but actually we're also getting more interested in looking backwards. So one of the real strengths, I think, at York is we've got a very strong history department and a very strong archaeology department. So we're now looking at ways in which we can begin to work with with people and experts in those particular areas to work backwards and begin to perhaps have a YCEO back in Roman times, which would be really cool. We're looking at extending our work to other regions, so other cities in the UK, other cities elsewhere in the world, and in particular some of the low to middle income countries where some of these issues are most acute. And just like the other two themes, what we are working towards is having a much bigger influence on policy at the national level, but also the international level, and sort of further developing our network. So just like Bob said in his presentation, if there's people in the room who have got an interest and feel they could contribute to the work of the theme, then please grab one of us afterwards at the wine break, and we'd be happy to talk to you. So thank you.
So with regards to the pharmaceuticals, obviously you can predict the amounts used with prescriptions, but how would you take into account the effects of over-the-counter medications?
That's an excellent question, and it poses a significant challenge for the estimation of some pharmaceutical concentrations. Take paracetamol, for example. It's almost exclusively used over the counter, and there's really nothing that we can do very easily to estimate the concentration of that without any data on sales, which is difficult to come by. So predominantly, we're able to get very close estimations based on prescription data where these are not over-the-counter drugs. But one of the other ways that we can go about that, though, is doing extensive monitoring, so measuring the concentration directly. And we have a sort of baseline then to approach the question that way. But
yeah, so one way we can do it is through consumer surveys. And it's one thing that we have been doing. So we've actually, and again, some of you may well have been involved in this. We did a survey of over-the-counter medicine use in York, and also to understand the disposal pathways. So how much was going into the waste stream versus how much was being used. And we can then use that data to begin to get an understanding of what the emissions to the environment are. So there are ways to do it. But I think, as John says, that data aren't always readily available. And I think as a society, we need to be much better in understanding the types of chemicals we use, how much we use them, and the patterns of use in our everyday lives.
Okay, more questions? Oh, there's one up there, right at the back. We're keeping our helpers fit, aren't we, up and down the stairs?
Hi, Jason Snape from AstraZeneca. Earlier on when Bob was talking, we were looking about the resilience of kind of agriculture and the food systems. Obviously, there are some parallels in terms of the production, the supply and the sourcing of medicinal products where maybe the pollution to kind of that was once maybe within Europe has been outsourced in terms of production to India, China and other regions. Have you got any prospects in the future of looking at the resilience maybe of the supply of human medicinal products like you are across the agricultural sector?
Yeah, so one thing that, and I'll hand over to John in a moment, who can tell you a little bit more about the project, but we've got a project on the go at the moment, thinking much more globally about pharmaceutical pollution. And the idea really is to try and understand the hotspots of pollution around the globe, and so that we can sort of begin to target sort of efforts at controlling the worst areas. I think we're also beginning to think much more broadly about the sort of life cycle of a chemical. Thinking sort of back to the feedstocks right through to the final product and the use of the product, and how we can sort of begin to sort of take all of that information together to assess what the environmental footprint of a chemical product might be. But John can say, I think, a little bit more about the global study.
Yeah, so Alistair's exactly right. We know relatively little, next to nothing in some cases, about how these situations extend to middle and lower income countries. And what we're finding through doing a project doing monitoring on 6 different continents right now is that the way in which pharmaceuticals enter the environment here in the United Kingdom is much different than the way they enter the environment in much of the rest of the world, and I think that's what you're alluding to in some ways. We're finding that once the production of drugs, for example, is outsourced from the European Union, to places like China and India, where regulation on the disposal of waste, which is created during the manufacturing process, is not as stringent as it is here. We find that that in some times you can find extraordinary high concentrations of these compounds that enter the environment through the manufacturing process that just wouldn't happen here. So I think we've got a lot to learn still about the implications of that on a global level, but we're starting to crack that egg.
Okay. Thank you. Those pesky EU regulations, I don't know. Oh, there's a question over there from Liz.
Thank you. This is right up to Sina. This is a question for Annabelle. Thank you.
No, I don't think it is, actually.
Okay, thank you. I thought your observatory idea, it shows enormous potential, and I'm really excited about this. And York's a fabulous city, but I kind of wonder, how does this fit into other cities in the UK and the world, and who's leading this? Is there anything we can learn from how they're doing this?
So York is the perfect place to do an observatory like this. We have a lot of expertise, as you've seen throughout the day, and a lot of different aspects here. And it's a nice size that we can set up monitoring and this integrated approach to collect the information, analyse it, and come up with some decision support at this type of scale. We do find that there are a lot of opportunities for scaling it up, and you can find a lot of analogies between York and many other cities. But as you say, there are a lot of different changes, and I think that what we can do, because the observatory is meant to be, at its heart, a very multidisciplinary place, we can use what we know of all of the data and the analytics, but we can also use all of the expertise to find out what's important, what are the important lessons for different places, and tie those not only within the UK, but to other places across the world. And I think that the beauty of the observatory is that it's so flexible in terms of its broad-scale idea that you can take a lot of that sort of the foundation work and you can apply it, but you need to be, as we've seen, you need to be very sensitive to what the questions are that you're asking and what type of information you need to answer it. Because obviously you can't apply it in one way wherever you are, and it's not just an automated switch that you go, oh, yeah, there's the answer to that question. So, yeah, it's a very interesting point, though.
Any more questions? Oh, there's one there. I think we make that our last question.
Hello there. My question is really around the fact that you have health and well-being as an element to the research theme. Are you doing any work specifically around mental health and well-being? It's the well-being dimension I'm quite interested in.
Yeah, so there are projects at the university looking at the links between the quality of the environment and well-being, and the part of this theme. So I think Steve Sinderby is somewhere in the audience. I think Steve has been doing, he's sitting at the very back. Steve has been doing stuff on environmental quality and well-being, and so we have colleagues also been looking at sort of green space and mental health issues. And when I showed you that diagram of this sort of the concept, that's the sort of thing that we'd like to work into it. So we've had people at SEI doing work where, again, Steve would be able to talk to you about this. They put headsets on individuals as they walk through the city to understand, how their brain was reacting to different environments. So yes, it is a component of what we're doing.
And there's a lot of expertise in mental health at the university, and Debbie mentioned right at the start the research themes that we have on campus, and one of those is on health and well-being, and we had a joint event between health and well-being and the environmental sustainability and resilience theme around environment and health. And of course, with the mental health and green spaces is very much at the heart of the government's 25-year environment plan, so very much a live area for us here in York. But I think in the interest of time, we'd perhaps better say thank you very much to the Urban Living team, and